in these sets of tutorials that are to follow, we are going to build on our basic mouse theremin. So we're going to take the basic mouse theremin, the different features of it. So right now we have a sine tone generator in SuperCollider. We have a very, very simple graphic user interface. In fact, it's just a black screen, but allows us to trigger notes with our mouse. And well, we did actually already add ultrasonic rangefinder there, so we can control amplitude. Now this is actually going to work together nicely with our ultrasonic rangefinder, so that we could do some different things with pitch. So in this first expansion module, if you will, we're going to expand these things. And I guess in expanding, we are going to learn a lot of concepts as we go. Again, sort of pursuing this thing where we're actually trying to build something, do something, but learning a lot of information, acquiring a lot of skills and information on the way. All right, so let's look at making a keyboard interface for our GUI. So right now, our mouse GUI mentioned is just a black screen right now. And what happens is, depending on where we are, it triggers some sort of message. Okay, so let's just have a quick, let's just remind ourselves really quickly, oops, what that is. So basically, we map the pitch. So we're taking the mouse X value somewhere between 0 and the width of our canvas, which is 1000, which is 800, I guess. And we're going to map it to just an arbitrary range that I set up, 48 to 72. And if you'll recall, those are MIDI notes. So I think that's the C, is it 1 octave? No, 2 octaves. No, 1 octave below middle C up to maybe 1 octave above middle C. All right. And then every time we press the mouse, we're sending this message pitch to SuperCollider, and we're adding whatever pitch this is, and that's that mapped number right here. And that just continuously maps in draw. And we're sending an amplitude. Now, we don't need this anymore because we're going to control the amplitude actually with our ultrasonic rangefinder, right? So we can actually get rid of that. Let's do a little bit of house cleaning. Let me save this as this one, empty GUI with, oops, with, we'll replace that one. Oops. Ooh. It's not letting me save here. All right, okay. All right, so empty GUI with continuous pitch. And we're going to go ahead and get rid of this amp. So we're not controlling amp any longer with our mouse pressed or the Y value of the mouse. Instead, we're getting amplitude directly from SuperCollider, from Arduino to SuperCollider. So let's get rid of that. And we'll get rid of these lines here. So we're no longer tracking the amp with our mouse. Okay, but keep the other code just because we might want to use that version, the click on and click off for other things, which is kind of nice. All right, now, right, and then just remember the triggers. So when we press the mouse, we send this message trig to SuperCollider, and we add the 1. So that opens up the envelope, right? It says trigger 1, it opens up the envelope and lets the sound. And when we release it, we send the message trig with a 0, and that releases the envelope, and it attenuates the sound. All right. So once again, we're not going to use those in this version because, let me get rid of these comments too. We're not going to use those in this version because we are controlling with our ultrasonic rangefinder. We're sort of using that as an attack, like a real theremin. So when we're all the way close to the rangefinder, it's no sounds coming out. You know, amplitude is 0. And get rid of that. We can also get rid of that one too as well. Well, we can leave mouse release for now. I don't think we're using mouse release, so we'll get rid of that. Okay. So really what we want to do is we want to have continuous pitch. So what we'll do is we will have this pitch, it'll be mapped here, and then we'll just continuously send it in draw. Okay, so it's going to just continuously send the pitch no matter where we are on the x-axis. All right. So what we need to do is just copy this code here. But like I said before, sometimes it's a good idea to just retype the stuff. So I'll go ahead and do that for a little practice, even though I've had plenty myself. See, I'll set a good example. Say OSC message, and we'll just call it the pitch message. Okay, and then it's going to be equal to new OSC message. So this initializes it just locally. So this is only available here in draw at this point, but that's fine because we only need to use it for a little bit. And we'll call that pitch because that's the OSC address, the thing we're sending. And then we're going to add to this pitch message. So now it's a variable that we can use once it's been initialized like this. We can use this variable pitch message, and we can enact a function on it called add, and that's going to add this pitch. It's going to add this pitch, which has been being mapped. All right, and then we'll send it. Okay, so networks are pretty fast these days. It shouldn't be a problem, but we are continuously sending this 60 times a second. This message, OSC message, is coming through. So in the mouse pressed version, it was kind of handy because you only send the message when we press the mouse. And we want to have some kind of control aid or something that does this. But now it's continuously sending this message every 60 times a second, which is fine. It's it's not a problem for the network and for the computer to handle. And we can just get rid of this mouse pressed altogether. Okay, so now we have a way to send out continuous pitch, and let's just go ahead and say that for now, and let's go ahead and look at this. Okay, my MIDI sign serial code handy. I'll go ahead and boot my server. I will send all this Arduino stuff, and then I'll start it. Now notice that one thing I did change here, and I think I mentioned this in the last tutorial, I did change this to trigger 1, so it's sounding already automatically. And then I have my ultrasonic rangefinder plugged in. Now you won't be able to do this unless you have the ultrasonic rangefinder plugged in. So if you want to do it and you don't want to bother having your circuit and all plugged in, you can just go ahead and just comment out all this bit right here. Yeah, just that whole bit, and then it won't look for your Arduino. All right, so then let's run this and let's see if this is working right now. So it just said continuous pitch. Oh, this is the wrong one. So that's already with the keyboard. Right. It should still work to send continuous pitch. Yeah, so it's continuously sending. So I can get that slide now. Okay, so we see that works. Let's just get rid of this super collider code for now. Till later. All right, that's great. Now, the other thing that would be good to do is to create on-screen keyboard so that we can actually know what notes we're playing. Obviously, a keyboard is a nice metaphor because it's familiar and it's like playing the piano. But of course, you can use anything you want. You can use letters that say A, B, C, D, or G sharp and things like that. You can use, circles, anything you want, really, any kind of object you want. Be explored. If you're not a keyboard player or the keyboard doesn't mean anything to you, you might try a different metaphor. So that's nice. These sort of interactive instruments do have these little areas, these little portals where you can develop and be very creative with. So think about that. If this is an area, if you want to develop a totally different interface that lets you situate what pitch you're playing, that'd be great. So, but in this case, I'm just going to make a keyboard as it's pretty familiar and already something that a lot of people use or are familiar with. So how do we do that? Well, we're going to do a couple things. First of all, as some sort of initial actions that will help us make our code easier later on, we're going to make some variables, change some of these things into some variables, and that'll make it handy for us to do some adjustments later on as well. All right, so I'm going to make a variable called an integer variable, int, and I'm going to call it w for width. Okay, and I'll just initialize it and put an initial value right here. I'll make it a little bit bigger than our 800 will do. Now, in order to use this w, I have to actually make that our actual width. I have to put w in here. So the size will be w instead of 800 there. Okay, we can do height as well. I might as well. int h, height for height, and we'll do that. We'll just keep that 600. We can probably even make it smaller, but and then we'll just replace that there, h. So that's going to help us later on because we're going to have to do some math with this. Now the other thing I want to make variables for as well are these pitch ranges. So and that will be helpful in a number of different ways. One is, we can change that pitch range up here as a variable, and then it'll allow us to sort of calculate with that variable pitch range. If we change it here, then it'll change for all the calculations. Okay, so these are floats, I guess, because this mapping algorithm, it's nice to have floats so you can get really accurate pitches. So we'll make those floats, and we'll call it pitch low maybe, and we'll make that equal to 48, and then we'll have another float, pitch high, and we'll make that equal to 72. Okay, so we can add those now. Don't forget to replace the variables in there, so pitch low, and then pitch high. Right, so if you've forgotten what this does, this maps the mouse value from 0 to the width. So in fact, we could continue to use the built-in variable here, width. That will be w or 1000, but we can also put in w if we want. But let's just leave it width for now. And it's going to go from pitch low to pitch high, so we have those defined here. All right. Now, in order to create a keyboard, we have to find out, basically we have to find out how many pixels each single pitch takes. So if we have a distance, say from, if we want to go to change pitch from middle C, 60 to 61, we got to find out how many pixel width that is. So that'll be the width of each of our keys. All right. So we'll just do a little calculation here. We'll create a variable here. We'll initialize it here, create it here, and then we'll assign a value down in setup because we're going to do a little calculation in setup. Okay, and that's a good thing to do usually in setup if you want an initial calculation. So we're going to make a float. Might as well make it a float. And we're going to call this px per pitch. Well, let's call pictures per step, or pictures per semitone, pictures per step maybe. Okay. And then we're going to do a calculation down here. We'll do it after the OSC stuff. We're going to say pix per step is equal to, okay, so how do we actually calculate that? Well, we're going to take the pitch high and subtract the pitch low from the pitch high. So pitch high minus pitch low, right? So 72 minus 48, which should leave us with, we say 2-octave range, so it should leave us a 48, right? Essentially, yeah. 24, right? Okay, and then take that number, whatever that is, and we're going to divide that into the complete width. So if we take the number of pitches, the width divided by the total number of pitches, we'll get the pitch per number of pixels per pitch, right? So we have pitch low, pitch high minus pitch low, and then I put it in parentheses because order of operations. Sometimes you have to some programs, and I think processing does allow for sort of an automatic. It automatically detects an order of operations. I think it will do like multiplication before addition, but I like to be certain, so I just always like to put parentheses in, and it looks clear in the code anyways because we know what operations are happening first. All right, so that's gonna divide into the total number of pixels in width, right, which is W. So width divided by the total, by these two, this minus that, should give us the pixels per step. So let's post that. So print ln, and we'll say px per, just to see if that's actually true, if it's working. So run that, and we should see it says 41 1/3. Okay, so good. Is that about right? It's about 41 pixels, 1,000 divided by 24. Somehow that doesn't seem right. Let's look at the old calculator there. So 1,000. I should be able to do this in my head. Yeah, okay. 41 1/3, or 2/3. All right. So great. So that works. That means that we need 41 2/3 pixels. Now pixels are, because they're whole pixels, because you don't do half pixels. That's the way the monitor works. We'll have to actually make this into an integer. So why don't we do this? Why don't we make this as an integer up here? So sorry about that. Gone back on myself, just to make it simpler. And then we'll convert this here in this, since we're doing all of our calculating here, we'll convert it. So there's a couple ways we can use a function called round. We can do that. We can just use the word int, and that'll essentially do the same thing round will. But let's do round. This will convert this into integer, and we'll put these in parentheses, that whole equation. So that means that this function round is going to work on all this stuff here. Okay, so what is that then? Round will take this pitch, this calculation, which is 41 2/3, and it'll round up or down according to basic rounding rules. So this will probably come to 42. All right. So yeah, so we won't print it again. I'm pretty sure that will work. That'll just round that, and then it'll convert it, the data type too, into an integer. So then that won't throw an error now that that's just an integer. Okay, so we're going to round that down. Okay, and then now what we have to do is we have to then create a keyboard based on that, right? So we know that then from 0 to 40, 0 to, we said it was about 42. So 0 to pixel 0 down here to pixel 42. Well, just run it anyways. So that means that pixel 0 to pixel 42 will all be in the realm of the low C, the C below middle C, right? Meaning that 0 will be this will be the actual here. 0 will be the actual pitch low, which will be, what do we say, 48. The MIDI pitch 48, and as we creep up, it'll be 48.1, 48.2, blah blah blah, all the way to, in 42 pixels, it will turn to 43, 49. I'm sorry, right? Okay, so then that'll be our key. We can paint it there. We can do something like that. So let's go ahead and do that, and we can simply do that by making a in draw. So we can label some of this stuff. This sends. Can say this sends a continuous pitch, MESSAGE OSC. Okay, and then we'll make a little header and we'll say virtual keyboard. Okay, so since we have this pixel per step, we know it's 42. We can just draw a rectangle there. So I'm just going to go no fill. And this is another opportunity to be a little bit creative. You can fill them and do however you want. And then I'm going to create a stroke weight. I'll say maybe 3, something like that. Depends how thick you want it to look. And then we'll make a stroke color of, we'll just make it white. And then we'll draw a rectangle. And I mean, I can use the whole screen if I want, but maybe I won't do it. I'll just have the top half or something like that. We'll make them, so the X will be 0. The Y will be 0, so the upper left-hand corner. The width, we already said, will be the the pix per step. So we'll just copy that variable and pop that in. That'll be width of our key. And then right, and then the height, it's whatever we choose. Let's say about half the canvas, or maybe a little less than half, 200 or something like that. Okay, so it draws a key, and well, let me print the pitch here so you can see. Okay, so we start at 48, like I said, and then we go 48 all the way to here, and that should be just about, oops, oh, 49, I'm sorry, it did turn to 49 right there. Yeah, so 49 right there. Okay, so that's one key. Now, we could go ahead and just do manual calculation. So then, if that's C, I guess the next one would be right. So we want white and black keys. So why don't we have a fill? We need a fill. And we're going to make that 255 as well. Okay, and then we can make no stroke. That's what we'll do. Okay, so we'll have no stroke and we'll have fill, so we can have white keys and black keys. Okay, and then if we want to, we can just have C sharp is going to be a black key. We'll have a fill 0, and then draw another rectangle. I'll just copy and paste this for now because I'm just actually making a point. Okay. And then we'll do right. So then we have to push it over, right? We have to push it over pixels per step. So we'll go start at 0, 0. So it's actually, we're starting at pixels per step. 0, we're starting at pixels per step now. So we're starting at 42 pixels in. The height's still 0. The Y is still up at 0. And the width is still the same, so that could stay the same, and the 200 height stay the same. So this is the only one changes. We just have to move it to the right slightly, right? The X has to move slightly to the right, and the fill is changing. So it's a black. You can't see it because it's black on a black background, but once we put the next white key in, you'll see it. So maybe we can change our background slightly to sort of a mellow blue. Forgot what my mellow blue settings were. 5, maybe 100. This will be like a purple, I think. Something like that. Oh yeah, maybe that's fairly bright. In any case, you get the point. Let's see, maybe it's 200 here. 100 there as well. Oh well. Anyways, we'll just keep it there for now. I'll find out my background properly later. So you see there, that's the black key next to it, C sharp. So, we could go through and do this 24 more times. Rather cumbersome, all right? But instead, let me introduce you to another concept, and that is the for loop. Okay, so I can iterate through a number of different settings, and I can using an iterator. I can just say repeat this thing so many times, and then make this slight change to it every time. And that's a much more efficient and easy way to draw these multiple keys. So I'm actually realizing that I do need a stroke, because even the keys themselves need to be defined from each other. So we'll put that stroke weight back. Sorry for the back and forth. We'll make it 3 again, and we will have stroke, and we'll make that black 0. Okay, so let's see how that looks. Oops. Semicolon. Okay, well that's good. So in case we have the two white keys together, we can tell them apart. Okay, so all right, so let's just take a minute here, and I'm going to make a new patch, and I'm just going to show you the for loop and see what that does. Okay, so the for loop, again, it iterates and it has an incrementer. Okay, so let me just show you the basic format and then explain what each part does. Okay, so you have a for, and then an open parentheses there, and then you have an integer. So you go int, usually it's I, and we'll start that at 0 equals 0, and then we'll have I is less than a certain number, let's say 10 for now, and I plus plus. All right, and again, let me just get this typed in and I'll explain to you what you do, and then the code that it's going to run within this for loop. Okay, so to explain things, basically you have an incrementer named I, and you can call it whatever you want because you're initializing it here with this int. So I have this, usually I, it's equal to 0. And then the next part of the for loop says it's going to count for as long as this condition is not true, right? So as long as this condition is true, I'm sorry. So it's going to count from I0 until I is no longer less than 10. Okay, so as long as I is less than 10, it will continue running this loop. Okay, and this is the incrementer. This is what happens after each loop. So it's going to run all the code in these brackets one time, and then when it comes back around, it's going to perform this action. So I plus plus is shorthand for I equals I plus 1. It's shorthand for I equals itself I plus 1. Okay, and you can actually write that in instead if you want to do that here. This is just a shorthand for that. All right. So then the next time, if it starts at 0, its initial setting is 0. If it comes back around, I equals I plus 1. The next time it'll be 1. Okay, and then it'll check, is 1 less than 10 still? Yes. Then I'll run the code. Then it'll go back around and I is equal to 1. So this is just the first time it does it. It doesn't do that anymore. I is equal to 1. And then I plus plus, now I is equal to 2. And it'll run the code I is equal to 3 all the way until I is equal to 10. And then is 10 less than 10? No, it's not. Then it'll stop running the for loop. Once this condition is no longer true, then it stops running the for loop. Okay? So this is handy in a number of ways. First of all, you have this increment I that is a variable that you can use that gets incremented. It goes 0, it starts at 0, goes 1, 2, 3, 4, 5, 6, 7, etc., etc. Okay? And then, so if we want to, let's just print line. And let's just do I. Okay, so if I'll get rid of that too. If we run this, you see it printed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it ran through 10 times, and it printed whatever the I was for that time. Okay, so that's handy. It's good to have that. And then you can just iterate this code. Okay, so if I want to if I want to say multiply by I can say print, I times 5. I can do all my 5s, the first 10 5s. So 0, 5, 10, 15, 20, etc., etc. Okay. So there you go. So that's what a for loop does. Now, these conditions and these sections are variable, so you can mess with those. So for example, if you want to start at a different number than 0, you can start at 2 if you want. Okay, and then if I run that, it's only going to print 10, 15 to 45. Okay, you can start at something other than 0, though 0 is often the most common. Of course, you can go to any number you want here, or you can have different conditions as greater than or as less than, so we can count backwards, which I'll show you in a minute. And then you can change the way it increments. So this I equals I plus plus. Okay, you can do I minus minus, which changes as well. You can do I equals, and I forgot the shorthand, so I'm just going to do it longhand. I plus 2. You can do something like that. So then it's going to start at 0, go to 10, but it's going to only do every other one. So 0, 10, 20, 30, 40, like that. Okay. Now, if you want to count backwards, for example, that's a good thing to do. So you're going to say I equals 10 at first, right? So we're going to start at 10, and we're going to say until I is equal to, while I is greater than or equal to 0, okay? Because we want to count all the way down to 0, including 0. So we're going to start at 10 and count down to 0. Oh, right. No, we'll start at 9 though, huh? Right. And then what you can do I minus minus, or I equals I minus 1. And that will count down. 45, 40, you notice that. Okay. So that's the way the for loop works. So it's a lot of flexibility. It's one of the cornerstones of any programming you'll do in any language, and allows us to do a lot of nifty things like what we need to do for our sketch now. All right. So this continuous pitch sketch now we need to draw a bunch of these rectangles, and we don't want to have to just redo them every time. All right. So I'm not going to worry about changing the colors. That's going to come later, and we're going to learn another concept. I'm going to now iterate this rectangle over and over again for as many times as I want. So it might actually be handy now to have some additional whatchamacallit. Sorry, we might be handy to have some additional variables, probably just one additional variable, which would be an int number of pitches, num steps. Okay, and how do we calculate that? Well, we kind of already did it here, pixels per step, except we're not going to have this division. So we're just going to go num steps equals, and actually if we calculate the number of steps first, we can put it in here, but that's all right. We already did that. We're going to round it because it needs to be an integer, and we're going to do pitch high minus pitch low. Okay, so right, if you take the high pitch and you minus the low pitch, that'll give you the total number of steps. But since they are floats, we have to convert into integer. And also, it might be that you might want a sort of a weird range. You might want to go to 48.25 to 72.9 or something like that. So that'll allow you to do that. I'm going to use a different rounding tool. There's two other ones. There's one called floor, okay, and that'll round always down. And there's another one called seal, and that'll always round up. So I'm going to use seal because I always want to round it up. It's better to have too many keys and not enough keys. The last key will just sort of fall off the screen, which is fine. If you don't have enough, then you'll be missing a whole key or a part of a key at the end. Okay, so I'll put that as the number of steps. Okay, so now that we figured out how many the number of steps, now we can do our for loop. All right. So right now we won't worry about the changing the fill here. Actually, I'm going to put that down here, so it'll be the last thing we do here. We're not going to worry about changing the white and black keys just yet. What we're going to do is we're going to just iterate this rectangle with using a for loop. Okay, so I'm going to go for int I equals 0. And then I'm going to go I is less than, and this is why we needed to calculate the number of steps. NUMSTEPS, okay? So I want as many keys as there are number of steps in my range, right? And then I'm going to go I++. Oops. Okay, and close that condition, and then have the two brackets there. All right, and then Command T tidies up your code. If you want to do Command T, it'll tidy up your code. So, right. So now it's going to do this, however many the number of steps are, I guess 24 times, and it's going to draw this. Now, if I ran this right now, it would just draw 24 rectangles on top of each other, right? Because it'll 0, 0. But we realized that the only thing we needed to change is the X. We just need to scoot it over. The width stays the same. The height stays the same. The Y location stays the same, right? So what we're going to do this in terms of I, because that's the thing that's going to change every time. It's going to go 0, 1, 2, 3, 4, all the way to 24, or 23, I guess, 0 to 23, making a fully 24 keys, All right. So how do we do this in terms of I? We can just do some simple math to that, and we can say it's going to be I times the pixels per step. All right. So the first time I is 0, so it'll be at 0, 0 with a width of pixels per step, which is 22 we said, and then 200. The next time I will be 1, so it'll be at x equals 22, which is the pixels per step, 1 times 22, 0, 22, 200. The second time it'll be 2 times 22, or 44, etc., etc., and it'll move over and keep doing it. So if we run this now, we should have a magical keyboard just appear for us. And there you go. Perfect. And for some reason, our last key is a little bit truncated. I think it has to do some of the combination rounding and such like that. But you'll notice it's still okay, though. And I think it has something to do with the strokes and stuff like that. So that's still 70, and that's still 71. Okay. Right, it doesn't quite get to 72. Because 72 is our furthest edge out. So if you wanted to include 72, I guess what you'll need to do is, increase your range. You can go from 40. If you want to include those two pitches, we can go from, we'll still go to 48, but we'll go to 73 that time. There you go. Okay. So that's a real easy way to get a keyboard using this for loop, and a good introduction to the use of the for loop. So just hopefully take that to heart. So now comes a tricky part. And it's probably, this is going to be a good example of some problem solving or ways to think as a coder. Not that I'm particularly versed in thinking as a coder, but doing some of these things, you start sort of thinking a certain way about how to solve problems sort of incrementally, really. So now we have to color in, if we run this, we have to color in if we want it to really look like a keyboard proper. So this is C, and that's C sharp. We want that one to be black, and that one to be white, and then that one to be black. You want 2, and then 1, 2, and then 1, 2, 3 black keys, etc., etc. All right. So there's a couple different things we can do. So first, let me introduce you to. I'll do two different ways, mostly for education, so we can learn about two different really important concepts. So the first thing I'm going to do is I'm just going to use an if statement, okay? And then, let me run this again, and I'm going to just look and see, and I'll just do the first octave for now, okay? So if I is equal to 1, that's my first key. I'm 0, and then I is equal to 1. So we're going to have black keys at I1, and that's I2 is white, I3, I4, I5, I6. So what did I say? 1, 3, and 6. Let's try that and see what happens. Okay. Now, this is one of the concepts we're going to deal with, and that's the if statement. And it's pretty straightforward. I'm sure you've used some version of this in real life, So basically, if then statement, really. It's what happened here? If, okay. And then in brackets, there'll be a condition. And then curly brackets will contain what happens if this is true. So if whatever's in these thing is true, then run this code here. So you can say if 1 is less than 2, then print hello. Okay, and it goes ahead and prints hello. If 3 is less than 2, or 4 is less than 2, it doesn't print anything, right? Okay, so that's basically an if statement. If a certain condition is met, then run whatever code is in here. All right, and it's, again, another cornerstone. Use these a bunch of times. I've heard it said once that, artificial intelligence is just, a million if statements put together. because you can get really complex patterns and such using if statements on top of if statements, et cetera, et cetera. All right. And then there's a whole, or I won't go too much into this, but if you want, one important one to know is if you want it to be equal, so 4 is equal to 4, since we have this single equal sign is an assigner really. So when we go back to our variables, for example, pitch equals that or W equals that, it just means that W, this variable, is assigned to this number 1000, right? We use the single equals. So for if statements, we need to use 2 equal signs. So 4 is equal to, I guess, is a way to think about that. Whereas this is really an assignment. It says W now is assigned to this number 1000 or becomes this number 1000. So that's the main one you have to remember. So if you're getting errors and it says something like, here, I'll run it. It says something like, it's not Boolean or something like that. Must be a variable, right? I guess they had an older error message, but the new one now says the left-hand side of an assignment must be a variable. So that's an assigner, right? So that's will come up. So if you're getting that in your code, chances are, and you'll do this a million times, I'm sure, when you start using if statements, chances are you only put 1 equals instead of 2, because that's the way we think. So there's equals, there's of course less than, there's of course greater than, there's less than or equal to, there's greater than or equal to as well, and I think there might be a couple others, but those are the main ones. Okay, so that's an if statement. If and then this thing is happens. Okay, so how are we going to use the if statement here? Okay, well, we're going to say that, so this is iterating through this I all the way to the number of steps, which we know to be 24, since that's 2 octaves. 73 minus 48 is, well, 73 is, because we're adding an extra key, so we can have that last octave before we run out of space on our canvas. So it's actually 25, whatever, but you get the idea. So yeah, so we're going to add the number of steps. So I is going to increment, so it's 0 every time and 1. So let's use our if statement to turn change. And then I'll show you the else, which is a pretty simple thing. So if we're going to say if I is equal to, remember 2 equal sign, and we said that 1. So the second one, remember it's increments from 0 because I is equal to 0. So 0 is white as our C. So C sharp needs to be black. So if I equals to 1, which will be the C sharp key, then make sure we put our curly brackets. Okay. Then this will happen. We're going to make the fill 0. Well, we won't use else actually because fill's already white here. Okay, so it's going to be white unless it matches that. Okay. So let's run that and see what happens. All right. Of course, we can't see it. Ah, right. Okay. All right. We will have to use an else. So we'll take that out of there. Okay. And we'll say, so with the if is a command called else. Okay. And you don't need to have these parentheses because there's no condition. It's just going to say, if this is true, then do this. But if it's not true, then else, it'll do whatever's an else. All right. So then we have our curly brackets for that. So if this is true, we run all the codes within those 2 curly brackets. Else, if it's not true, then you run all the code that's in these curly brackets. So in this case, we're going to do fill, and it's going to be 255. It's going to be white. Okay, so if I is equal to 1, it'll be black. If I is not equal to 1, it'll be white. And there we go. So we have the 1 black key. Okay. Now, so we're learning a lot of things here, and I know I'm going a little bit fast if this is your first time. If you know all these things, it's probably really boring for you. But we are sort of really building our coding vocabulary quite quickly in this one exercise. And this is sort of this whole lesson, this whole sort of course is designed this way so that we learn concepts by trying to do something. So we're trying to make this keyboard, and then we're sort of building our vocabulary, our glossary of things that we can use. All right, so we learned if, we learned else, we learned a for loop. That's a huge amount. you kind of do just about anything you want with just these few things. You can really do a lot of programming with just these few things. All right. So to expand the if a little bit, you can have these conditionals as well. You can have add-ons. Okay. And so you can say, for example, 2 ampersands here will be and. So basically it says it needs to meet this condition and another condition. If one of the conditions is false, it's not true. So it has to meet, and means it has to meet both. Okay. So, or, you can string those along as much as you want. So what's our next black key then? If it's 1, C is white, which is 0. 1 is C sharp. 2 is D natural, so that's white. But 3 is D sharp. So we'll say if I is equal to 3 as well, okay, then it'll be black. So either 1 or, I'm sorry. Okay, so and is that. So this will be I has to equal 1 and 3 at the same time, which we know to be impossible because it's incrementing through. So and will mean that it has to. So if I run that, no black keys should show up. Right, okay. So and means it has to meet both conditions. I has to be equal to 1 and 3, which it can't be. Okay. Now, and the other one is this thing called or. So which is these 2 lines together, line up line, whatever. I don't even know what that key is called, but in my keyboard it's above the slash. This one, it's above that key. Is that a forward slash, backward slash, forward slash? So 2 of those, which means or. So it means if either of these conditions is true, then we'll go ahead and do that. So if I is equal to 1 or if I is equal to 3, we'll do that. Okay, so now that should color in my black keys, and you'll notice now we have my C sharp and then we have my D sharp, which is nice. So, this is one way you can go through. It's not too cumbersome. And you can just go through and do that. And, that you should be happy with yourself if you just went ahead and just, counted up all the keys. So the next one would be, we're going to do 2, so 4, 5, and the next one will be 6. I equals 6. And then if I equals, and notice that you have to do the I equals every time. 6, 7, 8, et cetera, et cetera. Okay. And then, of course, this will be a third one there. You would go ahead and do that. Well, let's go ahead and put that in so we can see. I equals 8 or I equals 10. So we have our one register there, pretty much, back to middle C here. So our 1 octave, I guess. Yeah, so that works. And you can go ahead and just, it's not that hard to fill in 4 more and just count the keys. That's not too bad. All right. So you can do that way, and I think you should be happy with yourself if that's the case. So, however, if I wanted to make like a massive keyboard, if I have a big giant monitor and I made the width of my thing, like whatever, 2000, and my keys really narrow, and I had to make a whole bunch, then this might be a little cumbersome. I might have to do this 50 times or something. Or 100 times or something like that. So, and this is some good problem solving. It's kind of like doing a Rubik's Cube anyways. So, and I'm just doing this fresh right now because I actually did have it this way before, but I think there's probably an algorithm, a little trick, a little bit of math that we can do to figure out actually how to do it. All right. So, and we can do it by octave. Okay. And I also wanted to show you this one thing anyways. Okay. So if we're going to do it by octave, which is 12, we're gonna use this thing called modulo, and I'm not sure this is gonna work, but hang with me and let's see if it does work. So let me introduce you to this thing called modulo, okay, which is your percentage sign, okay. And modulo basically gives you, I've never really been able to explain this right, but I think it gives you the remainder, okay. So if you do 1 modulo 5, let's print. 1 modulo 5, it gives 1. How does that work? 2 modulo 5? Or it's the 2, let's say 7 modulo 5. Right. Okay. So Yeah. Well, anyways, I won't struggle too much to explain it, but it gives you the remainder. I guess the first five are for free. I don't know how exactly that works. So 0 modulo 5 is 0. So I guess there is no remainder because 0 goes into 5. Oh, okay. I guess 5, whatever. Anyways, so let's just discard the first 5 and let me move on. So if I do 5 modulo 5, there's no remainder, right? 0. 5 goes into 5 one time. So I guess it's this half that goes into this half. If I do 6, 5 goes into 6 one time, but it has a remainder of, 6. 5 goes into 6 one time with a remainder of 1. And then 7 or 8, say that, it had a remainder of 3, etc., etc., So we do, 3,000, 334, 5, whatever, some huge number, okay? It's going to give me some number between 0 and 4, right? Right. Okay, it's 3. So whatever huge number, I wouldn't be able to tell you, where that ended up, but the 3, well, I guess because it ends with an 8, and you can change that side to be like 13 or something like that. So it's the 7th. So that's a good way to iterate using modulo. It's a good way to sort of repeat this through, a pattern through, right? So in our case, we want to repeat a pattern of 12, right? We want to do a certain case every 12 things, okay? So the first thing we'll say, instead of saying we'll say if I, and I'll just actually leave these because we might keep these there. Right, so we'll do a kind of a combination. So we'll say if I modulo modulo 12, okay? If I modulo 12 equals 1, all right? So hopefully that will do this by octave. Now I'm wondering if there's even a more clever compact algorithm to take care of just the 2-3 pattern. But maybe it's just easier just to do it, 1, 2, 3, 4, 5 times. If I wanted to be real clever, I'm sure there's some kind of single equation that would encounter that says, it's going to do the second one and then the fourth one and then skip 2, et cetera, et cetera. I mean, I could be kind of clever and say use even odds. I suppose I can do that, but then that gets too complicated. Let's not get into that. We're just getting started, so let's not get too ambitious. So yeah, so at least this one will give you the functionality of doing it by octave, okay? And then once again, I'm going to put that into parentheses because that means that you want it to do the modulo 12 first, and then you want to see the result of that. Is it equal to 1? Okay, so let me copy that there and replace every I with I modulo 12. So it's just going to cycle through an octave, and it's going to say, is that equal to 10? Is I modulo 12 equal to 10? Right. Okay, and let's see if that works. And it does. So it's going to repeat that pattern all the way. So, for example, let's make a huge one. We'll have that 73. Let's do something outrageous like 200. Right. So it still does a 2-3 pattern, 2-3 pattern all the way through. Yeah. So that's nice, 73. So even if you change the range, it just automatically does that, repeats the octave for you. Okay. So there you go. So there we have our nice keyboard. And we've learned a bunch of concepts, modulo. We've learned for statements, if statements, and we've learned the else. So we've created ourselves a nice virtual keyboard there. And we've earlier made our pitch continuous. So if we run our SuperClouder code there, we can play with the keyboard. Now, you notice that that's like a thing and a half. So if we want to be really, really accurate, it's actually this, is the closer to the F, just the edge of it, and then this glides up until we hit the F sharp, right? So we can sort of push back everything, but I won't worry about that right now. Let's not worry about that right now. We'll just be slightly out of tune. Well, I mean, maybe that is something because if you want to play with live instruments. You might want to do that. So I think probably is. So we have to kill our. Let's kill that. Right. So yeah. So that works and it's nice, and we have that continuous pitch. And so sorry. Let me run that one more time. And just for a demo purposes. So if you're using my thing's at kind of an awkward location, but if we're using our ultra range finder, we can play a tune. And we can add vibrato too. Anyways, you get it. Okay. Let's just go ahead and actually do that last bit, which is to sort of, in case we want to play with live instruments, sort of move everything over. And I think probably the easiest way is just to sort of change this range a little bit. Let me think about this slightly. So if we're mapping, it's going to go from 0 to pitch low, pitch high. Mouse X from pitch low to pitch high. So if we basically let's print this pitch and see what it gives us. Oh, it's already being printed. Okay. What if we went from, half of the width here. So we have the number of pixels per step. What if we bend it halfway? So, it's halfway through the key. So if we map that from that, pixels per step divided by 2. Okay. And I'll just put that in parentheses. Probably don't need these, but just in case, just so it's clear. So it's going to go from, I guess in our case, it's like something like 22. So from 11, which is halfway through the key, to, so this is a bit tricky. We want it to go to, the middle of the last key, but what if we have like half a key? So that's a bit tricky, huh? So we want to go from there. So we want to go from the total number of steps times pixels per step. Right? So we want to go to the total number of steps times the pixels per step. So that'll take us to the very last pitch, the absolute last pitch, right dead on, take us to dead on, whatever it was, 73, hopefully. That makes sense? Yeah, the number of steps times the pixels per step. Or we can just use pitch high. Does that make sense? No. Okay, now we have to do this way. Number of steps times pixels per step minus this. So minus half of a pixel per step. Does that make sense? No, we have to do it plus because we have to go 1 over, right? So the end of the key is halfway into the next one? Right, because if we add this to the beginning, 0, it's no longer 0. It's starting from there. We have to add 1 to the end. So, I mean, simply, maybe we just do it like this. We just do it Let's see if that'll work. We just do it with plus pixels per step divided by 2. Okay, let's just try it that way. That's probably the simplest way to do that. And if we run that, so now midway through our key right here, we're at 48. And then 49 will be about midway through there. That's right. 50 about midway through there. So it works. Let's see if the 60 works. Yeah, it's about midway. And then let's see if that works right there. And then the last key, yeah, it kind of works. I think we're missing a pixel or two. I think it's adding half a pixel each time or something like that. Maybe. That's pretty much middle there. Oh, so that works. Okay. So there you go. So we've even corrected that. So that's really handy. So this thing here, this pixels per step plus 2 is just making it so that the center of our key is the actual dead on pitch. So if we're playing together with someone, we don't have to worry about being like towards the left of our keyboard key. You know, if we had it the old way, in order to play a perfect C, we'd have to be all the way over here instead of somewhere more towards the middle, you know. All right. Okay, well, that was kind of a lot of information and a kind of interesting project, and we added on to our mouse Theremin and made it a lot more functional. Now we can have a keyboard. And like I said, you know, since programming really is about complete customization, you know, ultimate customization. So, you know, keyboard metaphor is nice, but if you want to come up with, you can use these same principles, and if you want to come up with a slightly different sort of looking interface, or you can actually maybe look at some of the tutorials, some of the processing tutorials, and maybe add like pitch names. If you don't know your keyboard, you can do that, or you can just have like letters sitting there without the keys or something, or, you know, pictures or something like that. You know, that this is one possible way of, say, inventing a new metaphor of getting pitches instead of worrying about the keyboard, you know, in case you're not a keyboard player. Okay, so I think we'll wrap things up there, and good luck with that.